Students, welcome to the class. So in this section also we are continuing this section power series representation of analytic function. So there is a lemma. Lemma says that let gamma be a rectifiable curve in C. So suppose we have a rectifiable curve in gamma in C, and suppose that fn and f are continuous functions on trace of gamma, and if capital F is the uniform limit of fn on trace of gamma, then this integral over gamma f equal to limit integral over gamma fn. That means limit and integration are interchangeable only when the convergence is uniform, and this integration is done along the curve gamma. Okay. So in order to prove this integral and limit are interchangeable, I have to prove that the difference between them is tends to 0 when n is large. Okay. So I take some let epsilon be greater than 0. Okay. And since f is equal to uniform limit of sequence fn, sequence of functions, then by definition for the epsilon greater than 0 there exists a positive integer n such that I can write modulus of fn of w minus fw is less than some epsilon, and you take epsilon divided by v gamma or lambda gamma, that is nothing but the length of the curve gamma, and we have given that gamma is the rectifiable curve, therefore its length is a finite quantity, right? And what is this w? Because fn and f are defined on trace of gamma, therefore this w must be belongs to where w is an element belongs to trace of gamma. Okay, ready? Now consider the difference between these two integral values. So modulus of integral over gamma f minus integral over gamma fn. I consider difference between them. So which is equal to modulus of integral over gamma f minus fn. So which is less than or equal to integral over gamma mod f minus fn. Okay. Actually here it is d gamma with respect to d gamma. Okay. And this thing will be equal to integral over the trace of gamma, right? Some a to b, the limit of gamma, modulus of f minus fn of gamma of t, gamma dash of t dt. Okay. And we can add modulus here also. Okay. So what about this thing? This gamma of t can be considered as, because gamma of t is an element belongs to trace of gamma, so that this can be considered as some w. So this is fw minus fnw into modulus of gamma dash of t dt. Modulus of gamma dash of t dt. And this is by the uniform convergence we have modulus of fnw minus fw is less than epsilon by v gamma. So this will be less than or equal to epsilon by v gamma integral a to b modulus of gamma dash of t dt. So what will happen to this? And this is nothing but the actual length of gamma, therefore epsilon by v gamma into v gamma, this thing will be cancelled, so that we get epsilon. So in difference between them is less than epsilon. When n tends to infinity, this integral over gamma fn will be tends to integral over gamma f. So which proves the result. Okay, next we have a theorem. By using this lemma we will prove this theorem. Okay. So the statement says that let f be an analytic function in open ball of radius r with the center a. Then fz has a power series representation is of the form sigma n equal to 0 to infinity a n z minus a raised to n for mod z minus a less than r, or a n equal to 1 by n factorial to f nth derivative at the point a. and the series has radius of convergence that is greater than or equal to r. So it is something same as the Taylor series formula. So when we have a function which is analytic on in an open ball, then in that open ball our function will have a power series representation, and which is of the form sigma n equal to 0 to infinity a n z minus a raised to n, where a n is fnth derivative of a divided by n factorial. Okay, so how will you prove this theorem? Okay, so now first of all we choose 0 less than r less than capital R. We are choosing some radius small r, okay, such that B closure of a comma r is contained in B a capital R. That means we have a actually we have a open ball centered at A with a capital R radius. This is our BAR. Okay, we assumed that F is analytic in this region. Then Fz has this power series expansion formula. That is, we need to prove. Okay, in this region. Now we are considering a small radius small r which is less than capital R, such that its closure, the open ball centered at A with a small radius small r as radius, and its closure, the closed neighborhood of A with the center A and radius r is completely contained in BAR. Okay, ready. Now if r of t, we define gamma of t equal to a plus r e raised to it. This r is a small radius r. Okay, where 0 less than or equal to t less than or equal to 2 pi. That means in this region we are considering a circle with the center A and radius r, and which is denoted by the curve gamma of t. Okay, then by previous theorems I can write Fz can be written in that region in the smaller neighborhood of A. Fz have a representation 1 by 2 pi I integral over gamma Fw divided by W minus Z dW for the region mod Z minus A less than R. Okay, since mod Z minus A is less than R, and what is this W? W is an element belongs to trace of gamma. Okay, then you consider the term 1 by W minus Z. 1 by W minus Z can be written 1 by W minus A minus Z minus A. Right? So this can also be rewritten as 1 by W minus A into, this A can be taken outside, 1 minus Z minus A divided by W minus A. So W minus A taken outside, so that 1 minus Z minus A divided by W minus A. Okay, so that is equivalent to 1 by W minus A 1 minus Z minus A divided by W minus A raised to minus 1. Right, 1 by this thing and 1 by x can be written x raised to minus 1. Okay, so that is equal to 1 by W minus A into, what is this, 1 minus x raised to minus 1? You know the power series representation of this kind of expression. So that is equal to 1 plus x car plus etc. So here x is Z minus A divided by W minus AX. So 1 plus Z minus A divided by W minus A plus Z minus A divided by W minus A square plus etc. plus Z minus A divided by W minus A raised to n plus etc. This is the power series representation of the form 1 minus x raised to minus 1. Okay. So which is equal to 1 by W minus A into, this can be written sigma Z minus A by W minus A raised to n equal to 0 to infinity. So 1 by W minus Z can be written as some 1 by W minus A into power series expansion of the form Z minus A divided by W minus A raised to n. Okay, so by using this representation of 1 by W minus Z, Fz can be rewritten as Fz is equal to 1 by 2 pi I integral over fw divided by w minus z. We have fz is equal to w minus z dw. So this thing can be written 1 by 2 pi I integral over fw, okay, and this 1 by w minus z, 1 by w minus z can be written 1 by w minus a into sigma z minus a raised to n divided z minus a divided by w minus a raised to n sigma n equal to 0 to infinity, right? So dw, so which is equal to 1 by 2 pi I, okay, integral over gamma, okay, fw divided by this w minus a raised to uh, n plus 1. I will write it as w minus fz can be written, okay, this sigma is, I write sigma here, n equal to 0 to infinity, okay, integral 1 by 2 pi I integral over gamma fw and z minus a raised to n divided by, here it is w minus a raised to n and w minus a, therefore w minus a raised to n plus 1 dw. So this is our fz. Okay, now consider the term. Already we have mod z minus a is less than r and w is an element belongs to trace of gamma, right? Now consider modulus of this whole term, that is modulus of fw modulus of z minus a raised to n divided by modulus of w minus a raised to n plus 1, and this thing will be less than or equal to, and you can see that modulus of fw can be less than or equal to some m, because f is an analytic function, right? So therefore it is a differentiable function and it is a continuous function. So every continuous function on a bounded region is bounded, right? Therefore since f is continuous on b of a r, it is bounded, right? Therefore modulus of fw will be less than or equal to, modulus of fw will be less than or equal to some m on this region. Here z is okay, therefore that will be less than or equal to m divided by, what about w minus a? Modulus of w minus a will be less than or equal to, because w is an element in trace of gamma, right? That what is gamma? Gamma of t is equal to a plus r a raised to it. That means that is a circle centered at a and radius r. Okay, w is an element belongs to this boundary because it belongs to the trace of gamma. Therefore w will be belongs to this boundary. So what is the distance between w and a? That is equal to strictly r, right? The radius r. Therefore w minus a raised to n plus 1 will be r raised to n plus 1, okay, and modulus of z minus a raised to n. So which thing is equal to or less than or equal to m divided by r into mod z minus a divided by r whole raised to n. So r raised to n plus 1 is split into r raised to n into r, okay, ready. And what is mod z minus a divided by r? We have modulus of z minus a strictly less than r. Therefore modulus of z minus a divided by r will be less than 1, right? Since modulus of z minus a is less than r implies modulus of z minus a divided by r is less than 1, okay, less than 1. Therefore what I can write is, when this thing is less than 1, if you consider this as a common ratio, ഇതിനെ നമുക്കൊരു common ratio ആയിട്ട് വിചാരിച്ചു കഴിഞ്ഞാൽ, and the geometric series with the leading term, this will be convergent, right? So which implies sigma n equal to 0 to infinity modulus of z minus a divided by r raised to n is, this series is converges, okay, this series is converges. Mod z minus a divided by r raised to n is converges. Therefore when this thing is converges, this series is also converges by Weierstrass M test. Therefore by M test, Weierstrass M test, sigma n equal to 0 to infinity fw divided by w minus a raised to n plus 1 z minus a raised to n, its modulus is also converges. That means this term, this series with this term is also converges, right? This also converges on trace of gamma. Okay, therefore fz can be written sigma n equal to 0 to infinity 1 by 2 pi I integral over gamma fw, okay, this thing fw divided by w minus a raised to n plus 1 dw do z minus a, because z minus a raised to n. Okay, this integration is based on the variable w. Z minus a is independent of this w, therefore it can be put outside, taken outside. So this can represented as fz is equal to sigma n equal to 0 to infinity some term including the integration into z minus a raised to n. Okay, some term including this integration into z minus a raised to n. So if you take this as some a n, this fz can be written sigma n equal to 0 to infinity a n into z minus a raised to n, right? Put a n equal to 1 by 2 pi I integral over gamma fw divided by w minus a raised to n plus 1 dw, then fz is nothing but sigma n equal to 0 infinity a n into z minus a raised to n. That means fz has a power series expansion of the form a n z minus a raised to n. Ready. Now we want to prove that this a n has the record property a n is nothing but 1 by n factorial into f nth derivative of a. Yes, therefore fz has a power series expansion. Fz has a power series expansion sigma n equal to 0 to infinity a n z minus a raised to n, and note that this a n is independent of this z, right, on the region mod z minus a less than r. So that by previous proposition which is discussed in actually power series expansions in the earlier stages of this textbook, then for every n greater than or equal to 0, a n will be of the form 1 by n factorial into f nth derivative of a. So we proved that a n has this record representation. So when fz has the power series expansion on the region mod z minus a less than r, then its radius of convergence is surely greater than or equal to r, right? Therefore the radius of convergence of the power series will be greater than or equal to r, because it is convergent. The series is convergent on this region, so that this region has radius of convergence is capital R. Therefore the whole radius of convergence will be greater than or equal to that r. Okay, now there are some corollaries of this theorem. If f is a mapping from G to C is analytic and A is a point in G, then we know that by theorem fz has a series representation sigma n equal to 0 to a n z minus a raised to n for mod z minus a less than r. And what is this r now? Then r will be clear the distance between a and delta of G. That means that capital R is actually defined by the distance between the center point and boundary of that region. This is obvious from the theorem. And the second one also, when f is from G to C is analytic, then f is infinitely differentiable. Because when f is analytic, then we can apply this theorem for f, right? And you know, when f is analytic, f dash exists and continuous, right? So this theorem can be applied for f dash. And again we can continue this for its corresponding derivatives, successive derivatives. That means f will be infinitely differentiable. Okay. And the third one, if f from G to C is analytic and B closure of AR is contained in G, then f nth derivative at the point A also can be written n factorial by 2 pi I or integral over gamma fw divided by w minus a raised to n plus 1 d gamma, where gamma is defined by a plus r a raised to t, that is a circle with the center a and radius r. Okay, so how will you prove this? The third one, proof of third one. First and second one is obvious. Okay, for the third one, since f is a mapping from G to C is analytic, then fz, then by previous theorem, then by theorem fz has a series representation sigma n equal to 0 to infinity a n z minus a raised to, okay, that is fz can be written term by term a naught plus a1 z minus a2 z minus a square plus etc, right? So what will be f dash of z? Because f is analytic, its derivative exists, right? Therefore that will be derivative will be 0 a1 plus a2 actually 2a2 z minus a plus 3a3 z minus a square plus etc. So when you find out all the derivative at the nth stage, we get fnth derivative of z is equal to, you get n factorial a n z minus a raised to 0 plus some terms containing z minus a. Terms containing z minus a. ശരിയല്ലേ? nth സ്റ്റേജിൽ അല്ലേ, nth ഡിഗ്രി ആണ് ഇവിടെ ഉള്ളത്. അപ്പോൾ nth സ്റ്റേജ് എത്തുമ്പോൾ ഡെറിവേറ്റീവ് ദി power will be 0 plus some terms containing z minus a. So what will happen? Fnth derivative at a. At a, it will be n factorial a n itself. So which implies a n is equal to fnth derivative a divided by n factorial, right? A n has this representation. But actually by theorem we proved that a n is nothing but 1 by 2 pi a into integral over gamma fw divided by wm minus a raised to n plus 1 dw, right? Therefore from here fnth derivative of a will be n factorial into a n. That means n factorial divided by 2 pi a into integral over gamma fw divided by w minus a raised to n plus 1 dw. So this is fnth derivative at the point a. Okay. So by using this corollary, we can prove one more interesting result, which is called Cauchy's estimate. Okay. Cauchy's estimate says that suppose we have a region B of AR, that means center with the A and radius R, a region, okay, an open ball. Suppose that f is analytic in this region, f is analytic, okay, and also assume that f is a bounded function, f is bounded. Then modulus of fnth derivative, that means its nth derivative is also bounded, and that bound can be found by the formula n factorial into m divided by r raised to n. Okay, so how will you prove this? Which is an immediate result from the corollary, previous corollary. By using this result, fnth derivative of a equal to this formula. Okay, so by previous corollary we have fnth derivative at a equal to n factorial by 2 pi I into integral over gamma fw divided by w minus a raised to n plus 1 dw. Therefore what is its modulus? Modulus is nothing but which is equal to n factorial by 2 pi I modulus of integral over gamma fw divided by w minus a raised to n plus 1 dw. So which is less than or equal to, modulus of n factorial is n factorial itself, and modulus of 2 pi I is 2 pi itself, because modulus of I equal to 1, okay, and modulus of integral is less than or equal to integral of modulus. So for integral over gamma mod w divided by modulus of w minus raised to n plus 1 mod dw. Okay, so this thing is less than or equal to n factorial by 2 pi I. Okay, integral over gamma is there. Okay, mod fw, we have this function is analytic and bounded on this region. Therefore mod fw will be less than or equal to some that m. Okay, and modulus of w minus a will be less than or equal to r raised to n plus 1, because w belongs to the trace of gamma, right? ഈ ഗാമയുടെ ട്രേസിലായിരിക്കും. Okay, there is a gamma, this is our gamma, which is equal to a plus r a raised to it. This is a small radius r, right? So ഈ ബൗണ്ടറിയിലാണ് നമ്മുടെ w എന്ന് പറയുന്ന എലമെൻറ്റ് കിടക്കുന്നത്. So that this w, distance between w and a is equal to small r, right? Equal to small r. Therefore this thing will be less than or equal to small r raised to n plus 1 integral over gamma mod dw. Okay, so that is equal to n factorial, 2 pi I is there, m can be taken outside from the integration, r raised to n plus 1 is there, and what is integral over gamma dw? Integral over gamma dw means length of the curve gamma, and length of the curve gamma is what is gamma? Gamma equal to a plus r e raised to it, and this is nothing but the circle which represent actually z minus a equal to r. mod z minus a equal to r എന്ന് വെച്ചാൽ എന്താണ്, which is a equation of a circle with the center a and radius r. So what will be its length? Its length is its perimeter. Its perimeter will be equal to 2 pi r, right? 2 pi r. Okay, so that thing is equal to 2 pi into r. So you can cancel this term and r raised to n plus 1 and this r will be cancelled. So what you get, n factorial m divided by r raised to n. And this r will be always less than or equal to this capital R, right? So n factorial m divided by r raised to n is also true for f nth derivative modulus of f nth derivative. Okay.